Alright, so this is the example 5 of finding our second order partial derivatives. So 6 derivatives, first derivatives and second derivatives. Alright, so we've got an e raised to the 4x squared minus 2y. So this involves the chain rule initially. Alright, so first with respect to x. So f sub x. So the first part though I write down the e to the 4x squared minus 2y. And then it's the second part of the chain rule where it matters which variable I'm looking at. So I look at my function e. In the inside, I've got my 4x squared minus 2y, and so it's the 4x squared I take the derivative of, because it's with respect to x, so I get 8x. And so there's my derivative with respect to x. Alright, now I take its derivative with respect to each variable. Alright, so there's the first order derivative. If you want to rewrite it, you can. Move the 8x in front. I'm going to leave it alone. Alright, derivative with respect to x twice. And so I'm going to have to use the product rule, right? There are two functions of x. There's e raised to the 4x squared minus 2y. It's a function of x. And there's the 8x. It's a function of x. So product rule. Right, so the derivative of this is the first function is the e. The second function is the 8x. So it's e first times the derivative of the second, which is just 8, plus the second 8x, times the derivative of the first, which is the e term, times another 8x, right? Because it's the derivative of the e, which is itself, times the derivative of the inside with respect to x, which is where the other 8x comes from. Alright, then simplifying that, it's up to you. You could pull out the 8 in the e term if you wanted to. So 8e to the 4x squared minus 2y, which leaves me with a 1 in the first term, right? If I pull everything out, there's still a 1. And in the second term, one of the 8's are gone, but I still had 1 left over. I still had both x's, all right? X times x, which will give me an x squared, and then the e term's gone. And so that simplifies down to 1 plus 8x squared. All right, now the derivative with respect to x, then y. Alright, so this time though, there's only one y term. It's in the e term, right? The 4x squared minus 2y, right? The only part that has a y in it is the negative 2y. The 8x is just a constant. And so this time I don't have to use the product rule. The 8x is just going to come along as a constant. I take the derivative of the e term with respect to y. Well, the derivative of the e term is the e term, e to the 4x squared minus 2y. But I'm not done yet. This is the part where it matters that it's in terms of y. Alright, I take the derivative of the inside with respect to y. Well, the inside, the y part's negative 2y, and so I get a negative 2. And if I simplify that, it comes out negative 16e to the 4x squared minus 2y. And there's my mixed derivative. Which I should get the same thing when I go in the other direction. Alright, so there is it all in terms of x. And now I'm going to do the same thing all in terms of y. I'm actually just going to rewrite my function down here so I can look at it. Alright, so f of xy was e to the 4x squared minus 2y. Alright, now take it in terms of f sub y. So e to the 4x squared minus 2y with respect to y comes out remember negative 2. We just did that. Alright, the derivative with respect to y of the e term is the e term times the derivative of the y part, which was the negative 2, right, comes from the negative 2y. Alright, so the derivative with respect to y a second time, again, doesn't require anything. There's no product rule again. It's just negative 2 comes along. I take the derivative of the e term. Well, basically I'm going to get another negative 2 out, right? And so that simplifies to positive 4e to the 4x squared minus 2y. And then the mixed one. yx, not xy. Right, again, the negative 2 is just going to come along. It's e to the 4x squared minus 2y. But this time I'm going to multiply by the derivative of the x part. Well, the x part is the 4x squared. So I get an 8x. First, I simplify that. It comes out negative 16x e to the 4x squared minus 2y. And you'll notice that is the exact same thing I got up here. Alright, we did it in a different way, but I got the same expression. Alright, so that's the last example, and then we're going to get into marginal analysis application, and I'll do that in the next video.